Electrobel is part of the GDF Suez Group, a world leader in energy and environment, providing highly innovative solutions to individuals, cities and businesses. The GDF Suez Group is present on 6 continents and employs over 200,000 committed people. In the Benelux region, Electrobel serves 4 million customers and operates 100 power stations. Electrobel's generating facilities represent a diverse range of energy sources and technologies that include renewable energies, nuclear energy and fossil energies, a well-balanced energy mix that ensures that supplies are both economical and ecologically responsible. Using all kinds of energy sources will be essential to meeting future energy demands and will be vital to further develop renewable energy sources, as vital as the water that covers and flows across 3/4 of our planet. Today, we already harness the power of water, a natural, clean source of energy, to produce vast amounts of energy, hydroelectric power. In the southeast of Belgium, Electrobel manages a dozen hydroelectric power stations that all function in a similar fashion by controlling and channeling the speed and pressure of flowing water that power turbines connected to alternators to produce electricity. There are 3 different types of station. The first type is called a run-of-river power station. These can be found on the banks of the Amblève River, like the ones at Lossé, Edegora and Stavelot. This is the most basic type of station, where the turbines are placed directly into the river or a river's bypass. The quantity and speed of the flow of water through the turbines depends upon the profile of the river. The second type is a dam power station. Examples can be found on the banks of the Wash River, like the ones at Boutgembar and Robéville. At Boutgembar, a dam was built to create a reservoir along the course of the river. Turbines were then placed at the foot of the dam. Water in the reservoir is released as required to pass through the turbines to drive alternators to produce electricity. At Robéville, the river was also dammed to create a reservoir. However, in this case, when the water is released from the reservoir, it flows down through a giant pipe to turbines that are placed downstream that drive alternators to produce electricity. A third type of station, called a pumped storage power station, can also be found on the banks of the Amblève River, at the foot of a hillside at Caux-Trois-Ponts. This colossal engineering project started in 1967 with the creation of a huge tunnel sunk into a hillside. At the end of this tunnel is a room representing the heart of the power plant, where a series of giant turbines reside. These turbines are driven by water contained in 3 enormous reservoirs, linked together by vast pipes. The lower reservoir, the largest of the 3, contains more than 8 billion litres of water and was created by damming the natural course of the Amblève River. The other 2 upper reservoirs are situated on the top of the hillside. These man-made reservoirs were specifically built to each store more than 4 billion litres of water. Water is transported in 2 giant pipes, each of 8 meters in diameter, that are separated into smaller pipes, 1 for each turbine. The pipes transport 500 cubic meters of water per second to the turbines, enough to fill 10 Olympic-sized swimming pools in a minute. The amount of water flowing through the turbines is precisely managed and controlled by giant hydraulic rudders. These rudders regulate the power of each turbine that drives an alternator to produce electricity. Electricity passes from an alternator to a transformer into a high-voltage grid before leaving the power station. What makes the power station at Caux-Trois-Ponts so unique is that the flow of water between the 3 vast reservoirs can be controlled in both directions, so the station can either produce or store energy as required. This process is managed from a distance, from a dispatching centre in Brussels, and any demand is met within 2 minutes. When demand for power is low, electricity is sent from the transmission network to Côte-Trois-Ponts. This electricity is consumed by the alternators to power the giant turbines, which this time pump the water from the lower reservoir to the upper reservoirs. In this way, energy can simply be stored as a reserve in the water in the upper reservoir as an inexhaustible source of energy, ready to be released. When peaks in demand for electricity occur, the dispatching centre activates the power station again to release the water stored in the upper reservoirs. When the water flows back downhill to fill the lower reservoir, it passes through the turbines and its energy is converted back into electricity. In production terms, this station can deliver 1,200 megawatts of power for periods of up to 6 hours, which is the same generating capacity as a modern nuclear power station. And although the power plant at Côte-Trois-Ponts was finished in 1981, it still represents a phenomenal engineering achievement and is considered to be a reference in the world of hydroelectric power because it takes full advantage of the natural lay of the land. In the future, GDF Suez and Electrabel will continue to invest in diverse energy sources, and hydroelectricity will play its part in their energy mix that provides electricity to thousands of customers throughout Belgium and all over the world. Hydroelectric power. The force of water, the power of electricity.